Hello, my name's Carl. Welcome to my workshop and to my YouTube channel. Now I know I said in my last video, in the outro, that I was going to be going to work and there would be no more films. Well, my work departure was slightly delayed. I'm actually travelling this evening and then flying in the morning. So I've been able to make one last video for you, and it's going to be about the automation of the indexing process with a rotary table. So we'll be looking at my Vertex 6-inch rotary table, and I'll be showing you how I managed to fit a stepper motor onto it to do some indexing and automate the indexing process using an Arduino microcontroller to control the whole thing. And this has come about from the fact that I watched a video of John's workshop on Sunday, and he was having some issues with the dividing plates that reminded me that I could never get my head around those things during my training or at any other point in my career, and so I decided to make an automatic system of indexing. And it's based on the work of a gentleman called Gary Liming from the US, so you'll be able to see that and how it works. It's a general overview of the system that I made, and you can make one yourself as well. And I'll put a link in the description of this video to a little bit more detail that I wrote up online to a blog that I used to do a few years ago now. So I hope you enjoyed this video, and I'll see you on the next one. Take care. So as I've said to you, I've got just enough time to make one more film for you, and so I decided to give you a look at my Arduino controlled rotary table. Now I was watching John of John's workshop on Sunday, and he was doing some dividing with his universal dividing head and the dividing plates, and that reminded me of this thing that I made about 8 years ago now, because I needed to do a job with some dividing in it, and I was really sort of cognizant of the fact that I made a lot of errors over the years using dividing plates, and the material that I was using for the project I wanted to do was 316 stainless steel, and it was a fairly big piece of hollow bar, and it was very expensive. So if I'd made a mistake, it would have scrapped the part. So I decided to try and find a method of basically automating the whole dividing process. So I knew a little bit about microcontrollers, having dabbled with them over the years, and I didn't really have the time, or to be honest with you, the skill to program my own system to make it work. So what I did was I looked around on the internet to try and find a system that already existed that I could adapt to make my rotary table work with a stepper motor. And whilst I was doing that, I came across the website of a very clever gentleman from the US called Gary Liming. And he'd managed to make his own indexing fixture and motorize it with a stepper motor and an Arduino. So I wrote to him and I asked him if he would be happy for me to lift his system, basically, and use his software as was, and bolt it to my rotary table, and he was completely happy with me doing that. So basically what I've done is, you can see here I've fitted a stepper motor to the rotary table, and then I've got this control box here which houses the electronics that drive the stepper motor to give us the amount of rotations that we want to achieve the indexing that we need. So I'll take you in now a bit closer, and now you've seen the general setup. I'll show you how the motor is fixed to the rotary table and explain how I went about doing that. So here is the stepper motor. The reason it's got a shaft on both ends is because 8 years ago my intention was to make a handle to mount onto this the shaft protruding here, so that I could still use the rotary table manually. I don't know if anyone else has got as bad habits as I've got, but I still haven't managed to do that, so there you go. This is a NEMA 23 frame size stepper motor that I bought from a place called Zap Automation here in the UK. So this is 2 amp holding and a 1.89 Newton meter holding torque stepper motor with a 1/4 inch drive shaft. So the mounting for this basically is made up of a piece of 6082 aluminium tube, and then I've got this piece of squared up plate here which has got a recess faced in the front of it for this to be fitted into. And then here we have a circle of 6082 cut from a piece of bar, which is then spot faced so that the tube recesses into it. And inside, you can't see here, but inside here, this round plate has got 3 holes drilled into it, and it bolts onto the front face of the rotary table where the shaft is, where the handle would normally go. And this assembly here is held together with basically high strength epoxy, 2-part epoxy, and there's a slot milled in the top, so I can gain access to the coupling between the motor and the drive shaft of the rotary table. And I'll show you that coupling in a bit closer up in a minute. It's basically just a bellows coupling, and then the motor's held on with these M5 bolts. So the drive shaft on the rotary table is I think it was 12 mil, and it was a 1/4 inch on the motor, so that the coupling in there is sized appropriately for those 2 shafts to connect it together. So what you can see here is, excuse me, the rotary table drive, as all rotary tables have, is through an eccentric bush, if you like, which then is adjustable by undoing this clamp here, which I don't know if you can see that very well, but there's a thumb screw here which locks this eccentric bush in place. So you can unscrew that and you can adjust this to basically take the worm out of mesh, the worm drive in here out of mesh, or you can finesse the meshing of it to reduce the backlash. So this is, let me just show you the rotary table itself. This is a Vertex 6-inch rotary table, and these are very common. A lot of people have these, and you'll see them a lot online. When I decided to motorize the rotary table, what I had to do was I stripped it down basically, and I cleaned all the grease out of it that was in it, and cleaned up the bearings, the plain bearings inside there, which were bronze bushes. And when I reassembled it, I used oil to lubricate it to minimize the drag and the stiction in the rotary table, so I'd get the most out of the stepper motor. And also I adjusted this very carefully to absolutely minimize the backlash between the input shaft and the output of the table. This is a excuse me, a 90-to-1 ratio worm in here, and that 90-to-1 ratio is taken into account in the software that the Arduino runs to calculate the number of steps that the stepper motor has to rotate to turn the table through the correct angle for the number of divisions that we want. So that's basically the mechanics of it. And what I'll do now is I'll show you the control box and the menus that has to allow you to operate the system. So here's an overview of the control unit. Inside here there is a power supply, the Arduino unit itself, then the LCD board, which is mounted onto the Arduino. I'll show you that when I come to take the lid off this, and we'll show you how it's all fitted out inside. And the power supply is just plugged into a standard UK mains socket. And then on the side we have this connector which unscrews. Watch out there, just make sure I don't knock it off the bench. And this is a locking connector. It locks pretty well, doesn't it? I can't even get it out. So there you go, that's a multi-way connector. Only 4 of those 5 pins are used for the stepper motor, and that's where the rotary table connects up to the control unit, and that allows me to store the rotary table and the control box separately. And the locking feature here with the screw prevents this from being sort of inadvertently pulled out when the unit's running, because that would damage the if the stepper motor was disconnected whilst running, it would damage the driver board irreparably, most likely. So what you've got on here then is these 2 selection switches. One, the menu system that comes up on this screen. You can scroll through the menu items using this switch, and then you can select using this button, and you can make further selections using this switch, and I'll show you how that works in a minute. So once this is plugged into the mains and power is on, the Arduino inside here immediately starts to execute the program that's stored into it, which allows us to operate the system. So I'll take the camera in as close as I can, try and get a good shot of the LCD screen, and I'll scroll through the menus, and try and give you a description of how the software actually works in determining how many steps to give to the stepper motor to rotate the table through the appropriate number of divisions. So I've decided to do this handheld because it's the easiest way I can get the camera to focus on the LCD display, which was quite difficult actually to get it to do that, and also show you what's happening with the rotary table. So the modes on here, we've got step. So in step mode, if I select it, basically we can select the number of divisions that we want, and then the unit will tell us what position we're at. So for example, if we wanted 4 divisions, obviously each one would be 90 degrees, and when we hit the switch to move the table either clockwise or counterclockwise, it would give us position 1, then position 2, then position 3, and finally position 4. So that's how you would do dividing by the number of divisions, and you can select as many divisions as you want of 360 degrees. Now the way that this thing is set up, this is a 90:1 rotary table ratio, as I said before, of the worm drive, and then it's a 1.8 degree stepper motor, which is 200 steps per revolution. But because we've got this 90:1 ratio, we're looking at 18,000 steps per revolution. So you can do the maths yourself, and you'll see if you do that basically any division that we would practically want, we're going to get more than enough accuracy for the needs of the home workshop, or indeed for any workshop really, from that setup. So I'll continue to scroll through the menus. Just give me a minute for this to there we go, it's focused. So we'll go back to the main menu and we'll start stepping through or scrolling through the menu. So the next one we come to is angle. So if I select that, I can put in any amount of degrees that I want the table to move through. Excuse me. So if I put in, say, 60 degrees, the table will move through 60 degrees and then stop. And then if I hit the switch again, it'll move another 60 degrees and stop. So that's one way that you could, for example, you could lay out some holes on a PCD. If each hole was 60 degrees apart, you could just tell it to move around 60 degrees each time, and it would do that. So we'll come out of that mode now. The next one is jog. So if we enter that mode, we can see it's asking us for how many steps per jog, and we can change that. So we can have 1 step per jog, we can have as many as we want, and then as we hit the button, it'll jog round. We'll come out of that and go on to the next one. So the next one is ratio. I've got a bit of switch bounce going on here, which is a little bug that this system has I've got to be aware of, and I need to do something about it, but it'll serve the purpose of demonstrating it for you today. So ratio, if we select that, it allows us to select what ratio the rotary table is that we're connected up to. And as you can see here, I've got it currently set to 90:1. But I think there's 40:1 and 15:1, I think, as standard, which is what Gary Liming set the software to be. But you could go into that software and you could change that to whatever ratio you wanted, to reflect what type of indexing system you were using, even if it was a homemade fixture. And then you could make the algorithm in the software work using the ratio that your system has. So the next one is temperature. I don't use this. It's so you can actually monitor the temperature of the motor with an external temperature sensor, which I haven't got. So we're back to step again. So that allows us to select the divisions and the position. I'll show you how that works in a minute. And angle. So that's us move through all the ratios, all the menu items. So let's go to step, and let's select 6 divisions. 1, 2, 3, 4, 5, 6. So I'm doing that using this switch here. You can use any sort of buttons you want or any sort of switches you want. These are actually piggybacked onto this PCB inside the unit, which has small push buttons on it. It's called an LCD shield, and I'll explain more about that in a minute. So it has buttons on it to allow you to control the Arduino, and those buttons are these switches rather are piggybacked onto those buttons, as is this one. So we've told it we want it to move through 6 divisions. So if we go to the first one now using this switch, so you can see it counting down there, and I'll show you that the table's moving now. So that's going to the first division. And you can see it says position 1. So let's move to the next one. Steps per division 3000, as you can see there, and it's counting down the steps that it's moving to move to the next position. Yep, so position 2, so we can go ahead and move to position 3, and it's counting down the number of steps it has to do to get to that position. So you can see that that works fairly well. What I always try to do with the unit is always move it in the same direction, obviously as you would with a rotary table that was operated by hand. Just to try to minimize any backlash that might be present. So let's come out of that menu now. So let's go to angle and select that one. So I can tell this now to move, let's tell it to move 90 degrees. Well, let's see, it's going to take a while to get there. But you can see how this works. You just put in the number of degrees that you want it to move through, and it'll then calculate the number of steps required to do that and move the table the number of steps needed. Actually, we'll go to 60 degrees. Let's make it 40 because we're going to be here all day otherwise. So now I can move it round 40 degrees. So if we look at where we're at now on here, I know it's not very accurate, but I'll try and show you that we're going to get 40 degrees. Yeah, there is obviously some parallax error there, but let's move it and you'll see it is accurate. We'll see what's going on. So hopefully you can see that the unit moved through 40 degrees there. And if I hit the button again, it'll do the same thing. And it'll just do that all day long as I keep hitting that button. So that's another way that we can use to index with this unit. So there's a close-up of the coupling, and I'll just operate the unit again and you'll be able to see that rotating. So that's the stepper motor turning the input shaft of the rotary table. We're moving through 40 degrees again as we've just done, and then we've stopped. Right then, you've just seen me fumble the lid off the die-cast case that the electronics are housed in. So when we look inside, the first thing we can see is this 6 amp 12 volt switch mode power supply to run everything, just to give it enough headroom. So we've got the mains entry here running into the power supply. I hasten to add it is unplugged as we're looking at this. And then we've got the 12 volt output coming from the power supply, which runs into this main stack of cards here. So what we've got in this stack of cards is the the bottom one, I'll try and get the second best pointer in so I can show you this better. I tell you what, I'll use this screwdriver. So the lower one is the LCD shield, as it's called, and I don't know if you can see very well there, but that plugs into the Arduino itself. The Arduino is this board here, and then the LCD shield plugs into the Arduino. The Arduino microcontroller system is a really good little system, and it's designed to have different peripheral units plugged into it to make it easy to configure different circuit elements. So one of these is an LCD control unit, which plugs in like this, and it plugs into these headers on the Arduino board itself. And you can just plug wires into those headers as well if you want to, if you're doing experiments with a breadboard or something like that. So there's a little potentiometer there which controls the brightness of the LCD display. So then, mounted on top of the, you can probably hear the window cleaner knocking about, he's outside. Mounted on top of the stack of the LCD shield and the Arduino, we've got this stepper motor driver board, which is based on a Toshiba, I think it's TB6560 if I remember rightly, stepper motor driver chip, which is basically an H-bridge driver. So the LCD display shield also has the buttons on it, and you'll remember I said that I piggybacked onto those buttons to have these switches on the front, because they're only little push buttons, they're not really rugged enough. So there you can see the buttons and the switches piggybacked with these obviously wired up to the LCD shield. This is the leads coming from the stepper motor driver board onto the multi-pin connector on the side that I showed you earlier on, and then it's obviously through to the stepper motor itself. So that's how the electronics are assembled inside the unit, and I had to make a few little alterations to some of these cards to get them to fit in here. So this potentiometer here was originally on the top of this board, and I had to move it underneath so that it would fit in and fit through the cutout. Obviously that LCD unit is just slid through a cutout in the die-cast case box, and everything's held together with these standoffs and 6BA nuts and bolts. I've also had to move this smoothing capacitor here on the stepper driver board. I had to just move them because they were standing up, so I just put them onto some longer leads and put them at the side so that the board would fit into the sort of the footprint of the stack of the Arduino and the LCD shield. So that's how everything's assembled internally. There's I used to run a blog called British Reaction Research, and it was back in the day when I had some kind of ambition to build a rocket engine, and I had the sort of temerity to think that I would be able to do that. And if you go onto that British Reaction Research blog, and I'll put the link in the description, there's a far more detailed explanation with photos of how I built this, because that was before the days when I had a YouTube channel. Before I even thought of doing anything like this, actually. But I still had a workshop and I was still building things, so I documented it all on there. And I would also advise you to go to Gary Liming's site as well, and I'll put a link to that into the description as well, so you can have a look at the original iteration of this system. This is just my version of what he did, basically. And all these parts are very easy to get hold of. These power supplies are on eBay and various other places, and they're cheap. The Arduinos are cheap as well. You don't have to buy a genuine Arduino. There's lots of copies out there that work in exactly the same way. The software for programming the Arduino is free on the Arduino website. It's quite a good system, actually. It's quite a good development environment for programming them. And the LCD shield that's connected to the Arduino I got from a place called SaneSmart. There are other ones on the market which require slightly different values in the software for the button presses to recognize the button presses, but Gary deals with that quite extensively on his website. and he even came up with a piece of software to allow you to test the shield that you've got to make sure that it will work properly with the system. So that's basically it. That's a general overview of my my method of indexing, and there's the table again with the plug disconnected from the stepper motor this time. Yeah, so that's how I do it. I've made so many mistakes in the past and wrecked so many parts trying to use the dividing plates, and I don't trust myself with them basically. So yeah, this is the system I came up with to relieve myself of that particular chore, based on Gary Liming's work. And this actually got written up in an issue of Model Engineer's Workshop. I forget which one it was now, but I think a few other people have built this system now, more or less to my design, the way I did it. But obviously it's all based on Gary Liming's original work. So there you go. I'll leave you with that. And yeah, maybe you'd like to build one yourself. If you do, drop me a line. I'll throw my email into the description as well, along with the other links. So yeah, you can get in contact with me about it. Well, that really is it this time. I know I said it was last time, but you got me back for one more film. But yeah, that's it. As I said in the intro, I'm leaving this evening. That rhymes. I'm a poet and I don't know it. I'm leaving this evening to stay in a hotel and then flying out tomorrow to the ship that I work on. So there'll be no more videos now for about 4 weeks until I get back. So I hope you all managed to keep safe in that time and enjoy the time spent in your workshop. And I hope you've enjoyed this video showing my Arduino controlled rotary table. I certainly had a lot of fun making it and using it. I haven't used it for quite some time now, but it's done great work for me in the past. And it's about 8 years ago now that I built it, so it's I've had it for a while now. And it's definitely proved its utility. So I was thinking the other day that I'm actually coming up to a year now since the first ever video that I posted on this channel, which was a look at the workshop as it then was. And it's not particularly good. Not that any of the others are any improvement on it, I hasten to add. But in the time that we've been going, this year that I've been doing this now, I've managed to get up to 98 subscribers now. I was saying just the other day that I hoped I would get to 100 by Christmas, but it looks like I might be able to do that a bit sooner now. So I'm really, really pleased with the way things are going. And thank you so much if you've subscribed to this channel. And if you're watching this and you haven't subscribed, please do so, because it can only make things better and spur me on to improve things and make better films. It started off shakily, I think, this channel. I didn't really know if I wanted to do this and if I was going to enjoy it. And I've got to be honest with you, the first couple of films that I made, I started to think to myself, this is just getting in the way, you know, the camera's getting in the way. It's spoiling my enjoyment of something that, you know, that I really get a lot out of in my life. My workshop is a big thing for me, and I really do. It saved me in the past. And I'll explain what I mean by that in a minute. But as time's progressed, I've started to adapt to working around the camera, and it's almost starting to become, hopefully, fingers crossed, very tentatively saying this now, second nature to be recording things as I'm working and doing things and explaining them as I'm going along. Not only that, I'm finding that it's helping me as well. It's helping me to do things in the workshop, because explaining them to you, however noddy it might seem, because I know that the people that are watching this, you all know what you're doing, and you know, you've got years of experience as well. So, but it helps me to, my thought process, to work through things as I'm doing jobs in here, to be explaining them as I'm doing them. So that's good. Now, what do I mean by the workshop saved me? Well, people that know me will know this already, but I'm going to just let you into this little thing now that about 9 years ago now, well, exactly 9 years ago in fact, my daughter died. She was born with a very rare genetic condition, and she only lived for 8 weeks, and my wife and I looked after her for those 8 weeks and tried to give her all the love and all the we put everything into her. We gave her as much love and as much affection, as many cuddles as we possibly could. But unfortunately, the condition that she had was incompatible with life, and very sadly, she died after 8 weeks. And she's up there now, watching over me. She's my little butterfly, flutting around up there with my great grandparents and my grandparents, my granddad who taught me so much about engineering, and my grandma who basically brought me up and showed me the way to go in life, as did my grandfather. So my daughter's up there now with them, and I'm sure she's looking down on me. And if she was around, she'd be in here with me doing things, just like Harry is. And but I know she's with me every step of the way. And people said to me when she died that it would get easier as time went on, but I think that's very different when you talk about losing a child. If there's anyone watching this who has lost a child, my heart goes out to you, because I know what it's like, obviously, and it's a grief that never leaves you, really. It's a sorrow that never goes. It's ever present. It's like a shadow in your life. But it's a shadow, that you get used to, and that you can live with, and you can move on with things and move forward, as she would have wanted me to, I'm sure. And my workshop is one of those things that keeps me buoyed up and keeps me moving forward. So for that, I am eternally grateful to the big fellow upstairs, not only for looking after my daughter, but for providing me with something that that I can do and that can keep me going and keeps my mind on the straight and narrow, so to speak. Anyway, that's enough sadness and enough dwelling on things. I really hope that you all enjoy the time that in your workshops, and please look out for more videos, because there will be more. I'm really starting to get into this now, and the subscriptions going up is really starting to encourage me to carry on. So thank you very much for that, as I've said before and many times in the past. So until we meet again, take it easy, look after yourselves, and I'll see you in about 4 weeks' time. Okay, see you soon.